Hi, today we're going to look at solving a system of inequalities, a system meaning more than one. So we have two quadratic inequalities that we need to put down. First one, let's take a look at, we're going to use blue color to get there. Before you do any kind of quadratic, the first thing you need to find is the axis of symmetry, make a table of values, and then graph those points. So axis of symmetry, we are using that formula. X equals negative b over 2a. And pick out those numbers. We have negative 4 all over 2 times my a value 1. Okay, giving us negative 4 over 2, which is negative 2. When we make a t-chart, axis symmetry, middle of the graph, t-chart, middle of the graph, negative. Let's find two numbers smaller, negative 3, negative 4, two numbers larger, negative 1 and 0. And just remember when we plug these numbers in, these two answers and these two answers will match up with our y values. So let's take those 5 numbers, let's substitute them in. So we're going to say negative 4 squared, 4 times negative 4, and 5. And actually, you know what? I don't want to do that. I don't want to mess with 4s. Give me a smaller number. Give me a 0. So let's take these out. 0 and 0. 0 squared is 0 plus 5. Oh, that's much better. Get a 5. Answer up there is 5. Cool. Let's do it again. This time, let's plug in negative 1. So negative 1 times negative 1 is positive 1. 4 negative 1, negative 4, and a 5. That's going to give us a 2. Congrats. There you go. Do it one more time. This time, we're going to put in a negative 2. So negative 2 squared is going to give us positive 4 minus 8 and a 5, giving us negative 4 and 5, 1. Great. So let's try and graph this one first. Let's see where we go with that. We're going to have a dashed line. There's no equal sign. So plot the points, connect them with a dashed line. So we're going to go back 4, up 5. Back 3, up 2. Back 2, up 1. Back 1, up 2. And 0, 5. Great. Once we have a dashed line, again, no equal sign means dashed. We also need to shade. Pick a point, any point, as long as it's not on that blue dashed line. Let's try and use 0, 0. 0, 0, super convenient. Things cancel out. Take it, plug it in for x and y. 0 equals 0 squared, 4 and 0, and 5, giving us 0 plus 0 plus 5. Is 0 bigger than 5? No. Statement does not make sense. That means this does not make sense. This doesn't make sense. But everything on the inside will. So we could shade everything inside this graph. All right, let's go through and do the same thing with the second inequality. This time, we'll do it in a different color. All right, axis symmetry first. So we're going to say negative 2 all over 2 times my a value, negative 1, giving us 2 over negative 2, which is negative 1. That negative 1 goes in the middle. Go smaller, go larger. We now need to take those 5 numbers, substitute them in. But we don't actually have to substitute all 5 because we know that things are going to repeat themselves. So let's just worry about these 3 on the bottom. Why these 3? I don't really want to deal with the negatives. All right, let's plug 1 in. So we're going to say negative 1 squared minus 2 and 1 and a 2. Order of operations says I do exponent first, then a negative. So 1 times 1 is 1. Bring down that negative. Cancel, we're left with negative 1. Get the same thing up top. Good. Do it again, this time with a 0. 0 squared is 0 with the negative, who cares? 0 plus 2, leaving us with a 2. And we have to do this one more time, this time with a negative 1. Negative 1, positive 1. But we have a negative out front, bring it down. Negative, negative, positive. So we've got 4 minus 1, giving us 3. Now we have all of our coordinates. Let's take all 5 of them and put them on our coordinate plane over here. So we go back 3, down 1. Nope. Yeah, back 3, down 1. We have back 2, up 2. Back 1, up 3. Over 0, up 2. And over 1, down 1. Okay. Will this be a solid or dashed line? No equal sign, meaning dashed. And another check as to, do we got the right thing going on? Well, we have a negative out front, meaning this graph is going to open down like what we did. There's a positive out front here, meaning we've got the regular U. That's good. All right, let's shade. Pick a point, any point, as long as it's not on the red dashed line. Again, I like this 0, 0 in the middle. So is 0 smaller than negative 0 squared minus 2 and 0 and 2, giving us 0, 0, 2. Is 0 smaller than 2? Is 0 smaller than 2? Yes, it is. I like this statement. That's true. So that means everything in here gets colored in. This is getting a little sloppy looking. So here's where it gets a little strange. We need to figure out, where does blue and red both overlap? Where are the two overlap regions? In this case, it's going to be that small little area. So now here's a question for you. I want to know where the solutions are. Where do we have a solution? So if I were to pick up a random point, we'll even use right here. Is that a solution? Well, it's definitely one of our coordinates, but since that point lies on that dashed line, it's not. It's going to be everything kind of like squeezed in, not touching the outer edge. Is this blue point a solution? Well, it's part of our boundary, but it's on a dashed line. Not going to be a solution. How about something inside on that white area, or on that black area right there? As long as it's inside, not touching that line, those dashed lines, we have a solution. So solutions, anything that's colored in. If it was a solid line would be a solution. Dashed line, not a solution. Everything on the inside. That is a system of inequalities.